I'd like to thank TWEC organization for its endeavors and studies it conducted before and during and after the organization. Although this is the second day of the session, I would like to thank our participants who are paying attention. I mean, although we are a new organization, this intense attention is very good in its second year, and this accelerates us as the shareholders of the sector. Thus, I personally appreciate the crowd here. In regards to REST project processes, actually we classified what we have experienced so far into three main titles. These are contractual processes, physical processes, which we frequently call as processes we encounter on site, and also the management processes we experience while properly managing these processes with our team. Contractual step of the project, which can be considered as a constitution, is very important because the project specifications, the truth about the project, problem-solving references of the project against any issues that we can encounter are of great importance. This is what we think. I would like to make it more concrete by giving you some examples. For example, the project we put into practice recently in the Kingdom of Morocco, we encountered with some critical issues. This actually showed us how much contractual steps are important. These steps should be examined in detail. As project supervisors, I want to make a little confession. As a person served both in the TWEC supervising and in the employer status, we signed a contract. We made an agreement with the tour guide company, but we did not want to be a reference to the papers signed. We didn't want to go back to that papers. All we wanted was a routine and on-site work. We thought we could take a look at the document when there's a problem. In the project in the Kingdom of Morocco, it was our first experience. The contract was already signed, but then we realized there was a problem in the definition of working days. In fact, the work program was clear. The work should be completed in 320 days. There are 22 turbines and 2.3 megawatt capacity. Work program, work processes are already defined, but working days are not defined. We wonder if we have to work on Saturdays and Sundays. And when there's a problem, you need to notify that body. The problem arose on Wednesday. If the contract wouldn't be sent back, then there would be a problem, and the party that realized this problem lost its right on the matter. For instance, that 5 days include Saturday and Sunday. Although these seem minor, but when we examine them in detail for future references, for managerial steps, and when a problem arises, the only address is that contract. As the professionals, we need to examine this carefully. Mechanical completion criteria, which define the mechanical process. Again, I will give the same reference. It wasn't clear. As an employer, you receive a work. They need to notify you according to which criteria this job is completed. But as you contractually don't know, then you have some concerns whether to receive it or not. As these items are not scanned carefully at the very beginning, risk factors appear. So according to my little example, these items, its definitions, its terms should be explained when we are at the contractual step is very critical. I can give you many examples on this regarding the additions to contractual step. In summary, contractual step is the most critical reference point, key point, so that the project can be done properly and on time and of good quality and according to specified targets. Both parties should understand each other better and should understand what the contract is saying between the lines. As professionals working in the wind sector, we generally work on top of the hills, at desolate places. The geographical conditions of our working area is tough. Weather conditions are tough. We were in the management of 560 megawatt capacity work in the field. Generally at locations over 1000 meters, we work under dense snow, 2 meters of snow. In summer we work at desert conditions, at 50 Celsius degrees, under sandstorms. Sometimes, no, rarely we find opportunities to work at lowlands. So again, geographical conditions should be examined carefully at the beginning of the project, because this profoundly affects logistics, and targets should be put accordingly. Again, I want to give an example. As an example to geographical and physical conditions, it is important that you work with expert companies. In one of our projects, it was not a turnkey project. I was the project director at that time. The company basically designed our turbine. It's a bit technical, but 450 or 500 cubic meters of concrete and 45 to 50 ton equipment is the ordinary model, but the design doubles these figures. This means we are going to open 2 bases instead of 1. So almost 800 cubic meter concrete and 80 to 90 ton equipment. But we became suspicious. Actually, we knew that this couldn't be done, but our partner is an expert company. We cross-checked this project with 2 different companies. Then our opinion became dominant, so we ceased to work with that company. Actually, employers increase the cost of the project 100% when they work with companies that are not experts. In a project with 20 turbines, such a false practice or any conservative attitude brings in 1.5 to 2 million euro extra cost, especially at steps when examining if the projects are bankable or not. This amount of money is very valuable. Physically, we can touch upon some other matters. Land conditions, these are very crucial examples. As I said, top of the mountains. Weather conditions. Actually, weather conditions are very critical because windy fields are generally hills. Anticipating the initiation date and the construction period are very important, so you manage your logistics and equipment according to this. It is very critical to safely transport the equipment to the field, because when you're in winter, then there comes frosts, dense snow, transportation for equipment mounting. Tough conditions are the greatest burdens. Thus, we need to pay attention to this. Otherwise, the team loses its motivation. While we are trying to motivate your team, you are on the other hand coping with tough weather conditions. At the beginning of the project, the struggle of people is about the financing. Just make this project happen. We will handle it one way or another. In January, February we did it. 2 months later or 6 months later equipment came. September and October we started mounting, but in November, December and January the snow became the greatest burden. So there comes the contractual step. Delay costs. Both parties begin to challenge each other. Thus, we need to examine this period carefully, which we can call work program. Finally, yes, this is a teamwork. I mentioned the contractual process. I talked about physical conditions, and I want to emphasize one more thing. It is the management step. The equipment is very huge. Towers of 40-50 tons, 80 to 100 ton lasers, 20 ton wings. These come from any European manufacturer or from other countries with great ships, and thanks to the organizational work of a team, the mounting in the field starts. This can be done in different ways. Without a proper scenario, for instance, mounting team, turbine team, electrical team, construction team can work individually in the field, but there has to be a group that coordinates them all. We have seen the importance of this in our turnkey projects. For instance, cable channel digging is required for electric purposes, but then you realize that 80-100 ton of equipment that you have been waiting under dense weather conditions on top of a mountain hasn't come yet. But due to this little cable channel or inefficient coordination among men, the work stops or is delayed. Then you become tense, collisions arise. So these things should be coordinated by an expert team. This is what we think. A proper team scenario, a site manager, a civil engineer, and a must-have workers, health and work safety experts should constitute a team, and this group should organize construction team, electric team, turbine teams in routine intervals, immediately intervene in any problems that occur, and this team should always be in contact with each other so that we can solve problems before they arise. So I wanted to emphasize these three aspects: contractual, physical, and managerial status of the project. For our experience, these three are a must. When one of them fails, big problems arise. So at İK Enerji, we wanted to emphasize these three aspects. Thank you.
Çok önemli. Sorunların ortaya çıkmadan çözülmesini sağlamak için. Ben kısaca bu üç konuya vurgu yapmak istedim. Kontratsal, fiziksel ve işin yönetsel boyutlarına. Biz bugüne kadar edindiğimiz tecrübelerde bu üç konu olmazsa olmuyor. Ve bu üç konunun bir iki tanesi aksadığı yerlerde büyük problemler çıktığını gördük. Dolayısıyla biz özellikle İK Enerji olarak bu üç konu üzerinde vurgu yapmak istedik. Teşekkür ediyorum.
You really mentioned very critical points. Consulting is important in Turkey, but generally they desire to get this consultancy out of charge with the equipment. Unfortunately, in Turkey we have to cover a distance to qualify those with international experience, those who gained experience during the construction of thousands of megawatt capacity. This knowledge is very valuable. Koray Bey talked about logistics. You may have seen Vatan newspaper today. I brought it, in fact. There's a news. What if it passed from the front side? A wing of the wind turbine is stuck into the back of the autobus. I guess the autobus overtook the vehicle that was carrying the wing. Normally, there should be a security vehicle at the back of that vehicle that carries that wing and should not let anyone overtake this vehicle. But maybe the driver of the autobus didn't care, so because of the angle of the wing, it stuck into the autobus. God's sake, nobody got hurt. So the planning here is very important. I apologize. There are many new people, young people here, and I'm very happy that this hall is full. I didn't introduce myself. I will then pass on to what Mert Bey talked about. After my experience in Siemens for about 15 years, I am senior electric engineer and doctor of management in management organization. I've been in the wind sector since drafts are being written. In Rüzgarlı Sarıgerme Iber Hotel, I was the former founder general manager of Vestas Turkey, and for 2 years I worked for Ağaoğlu. I constructed 2 wind power plants as a board chairman of Ağaoğlu Energy Group. So I have labor in at least 1/4 of wind power plants in Turkey, and I love to work in this sector. For 2 years I worked for a Swedish consultancy company, but now I am freelancer. Now I'm coming to the subject of Mert Bey. He will talk about the experiences in turbine foundations. When I was doing the Mersin power plants, for Ağoğlu Energy Group, but then it was sold to Doğan Energy. We hardly proceeded Şahrıza Ali Bey. We poured the foundation, we designed it, by talking with Vestas. Normally you need to wait for 28 days for it to get dry, but he wanted us to start building turbine parts before it becomes dry. We said to him we shouldn't do this. This has a calculation, otherwise this may cause a certain vibration. The company won't operate the turbine. He said, you cannot know construction better than I do, so build them. Eventually we persuaded him, but such things happen. But due to the cost we are trying to save at the bottom, we had so hard times to bring the turbines out there. Because as Karabay said, wind turbines in Turkey are conducted at very tough locations. It's actually very rare to construct a wind power plant in a lowland, but Turkish investors somehow cope with this. Logistics companies learn about this. We are learning about the right planning. Now I would like to give the floor to Mert Bey. Mert Bey is one of the founders of Gensel Engineering. In 2004 he graduated from İzmir 9 Eylül University Engineering, Civil Engineering, and he got master's degree in structural engineering in the same university in 2007. He had a professional business life of 6 years on structural designing, and then he founded Gensel Engineering with his partner Sardar Bey in 2000. They are designing the foundation of wind turbines. They are providing earthquake analysis for the foundation of wind turbines. They are conducting structural analysis based on structural steel design and performance. This is a very important subject. Most of the investors have construction origins, but they are not industrial construction companies. Unfortunately, the foundations we are pouring on top of a mountain are completely different from the foundations poured in the city center. I mean the turbines, the vibration, etc. So I'd like to give the floor to Mert Bey. Welcome everybody. I'd like to talk about the foundations which constitute an important item of construction. I did not prepare a technical presentation. This is mostly about the general knowledge. I want to make my presentation fast without boring you. I want to talk about spheres, sphere basic connection built-in systems, and foundations. And finally, I will talk about frequently used superficial foundations. I will give some examples with photos. Gensel Engineering is a structural engineering based project office based in Izmir. We are working in basic designs of wind turbines and the structural steel projects. We have experience in the foundation of almost 30 wind turbines. And since 2012, we are serving to our customers under Gensel brand. When we start from the towers, pipe tower is a system that we are all used to. Pipes have the same characteristics in both ways, in both directions, and they have high torsion characteristics. This is very important. Also, as it can be manufactured in individual parts, their mounting is very low compared to the others. Another positive attribute is that their maintenance costs, like screws, corrosion, etc., are very low compared to the other types. When we look at the dimensions of a 2.5 megawatt turbine, bottom diameter of the tower, up to 2.9 meters in areas above and equal to 2 meters. Wall thickness is again provides savings. Decreases from 42 millimeters to 15 millimeter in the region, in the location of the hub. The second one is the cage system braided towers. It is also called the lattice tower in the literature. As you can suppose, a less amount of steel is used in these lattice towers. As it is a multi-piece type, transportation cost is very low. You only connect them with screws. Thus, the basic costs are decreased. Thus, the most negative aspect of this tower type is the high maintenance costs. In a 20 years of economic life, you need to check 10,000 screws individually for 3 times. This is the most disadvantageous aspect of this type. This is something personal, but in terms of visuality, they are not as satisfactory as the twisted towers. The third tower type has license from an icon company and is now being practiced in our country. It is heavy stretcher ferroconcrete in the first 30 meters and the standard tower carrier design mounted on top of it. This system makes sense in regards to static. Loads and moments are much more at the bottom, so you use ferroconcrete to make saving. On the upper parts, you then again turn back to steel to decrease mounting costs. For instance, an icon company founded a ferroconcrete site, a facility. It is manufactured in segments and combined together with screw boxes you see out there in black. And towers are connected together to have contact through bottom stretcher pipes that are passing through it. And pressure resistance in these pipes is up to C50, C60. For the anchorage, the most frequently used anchorage system is bucket connection. On top there is a base plate, on the bottom there is an anchorage plate resistant to erosion and peel, and in between there are high resistant bolts for load transfer. These high resistant bolts move in a special plastic cover to enable load transfer to bottom plate, so thus it does not transfer the load to the ferroconcrete in the middle, but directly to the bottom part. As you can install anchorage bucket before equipment mounting, and after you finish up with the bottom equipment, you can prepare your bucket and in a separate place, and you can position it on your equipment by a lifter. Anchorage buckets differ very much according to turbine manufacturers and turbine types. You can pour concrete on the front plate's cotta, and through plastic or steel nuts left under the plate, you can handle it. The second connection type is using connection cotta. This is a connection with connection parts. You can think this as a child playing on a beach and sticking a rod in the sand. You are burying a certain part of the tower the pipe tower into the foundation. It was clear in the previous slide, but it is still clear in the slide too. You need to adjust the order of your equipment according to the holes left in this part. You need to use special joints at these hole areas not to have the equipment contact the steel. This is a frequently used method, but in the examinations done in Germany, especially at areas where steel connection pipe is connected, a piece connected is connected with the ferroconcrete due to the horizontal movement of the turbine. Fractures may occur and water penetrates from these fractures. And after this connection, in the area where ferroconcrete is connected with steel, they began to use special joints. The third connection is called the adapter connection in the literature. This is a method frequently used by GE company. Actually, this can be a composition of what I explained in the first 2 slides. Again, there is a steel pipe on top. This pipe transfers load to the bottom plate through bolts. I talked about the towers and the basic tower connection types. I will keep on moving. Foundation is a tough work. Actually, in civil engineering, any work that is subjected to load is tough. These structures can be up to 100 meters in height. In a 2.5 megawatt turbine, the load on the foundation is about 400 tons. While flying from Izmir, I looked at the catalog of Turkish Airlines. The load in Boeing 737 is 80 tons. So there is 5 airplane load on the foundation. The harder part for engineering is the tipping thrust. This tipping thrust at each twist of the wing provides loading and discharging cycle to your tower or foundation for about 20 years. As a result, we are trying to connect turbine, which is an active machine, to the ground, which is stable and whose attitudes we are trying to examine through cutouts and tests. And the foundation should provide a safe transfer in between. When we consider the costs, in terrestrial turbines, the foundation costs are about 9%, whereas in offshore foundations, the foundation cost is almost equivalent to turbine cost. Basic foundation systems are mainly divided into 4 divisions. High tipping thrust costs are covered with its own weight and the weight of the filling materials on top of it. The second foundation type is the piling foundations that transfer load directly to the carrier ground plate at the bottom. The third foundation has the piling style, but these are rock encouraged foundations used in stable bases. I will give details about it. And lastly, the single pile foundation, which I do not find applicable, but it is available in literature. Here you prepare a single concrete pile with a very wide diameter at the bottom of your turbine, and you pour your foundation on this. When we look at the attitude of superficial plate foundation, at first let me talk about the naming of the foundation. The area where the foundation contacts the tower is generally called the pedestal, and the area the foundation connects the ground is the footing. Tipping thrusts that are transferred from above are transmitted to anchorages as pressure on one side and pulling on the other side. The big moments above cause non-uniform tension distribution on the ground. New filling material we use to cover the foundation creates a positive value in statics. It provides positive weight in tipping and decreases the amount of upper equipment. When we look at the equipment, radial equipments are on the bottom, and on top there is trestle and cutting equipment to combine the equipment below. I will later on give details about it. Deep foundations applied on poor grounds. We transfer load directly to ground plate on the bottom. We are trying to distribute the piles to the outer wall of the foundation as much as possible in order to enhance the lever arm. As I said before, rock anchorage foundations are applicable for solid ground. As it is in the piled band, you distribute your ropes over the outer wall of the foundation and do the grounding from spaces. Then you pull these ropes through pre-stressing force and you anchor foundation to the rocks. Here is an example. The sockets you see shows the encouraged areas. Finally, I would like to talk about the frequently used superficial foundation. Its application begins with static calculation. It is better to classify static calculation as interior endurance and exterior endurance. In interior endurance, I only wrote down 8 of it. There are almost 50 investigations actually, and you have to do this for 3 times for the service load, overload and fatigue load of these 50 investigations. Fatigue control exists also in other elements of turbine foundation, in wings and tower, but in our country this is not valued so much. You need to do fatigue control individually for steel and concrete. It is such a complex calculation that you even calculate the bending diameter. When you unconsciously overbend the bending diameter, then you intentionally decrease fatigue endurance of the equipment. So we try to calculate even the bending diameter in our projects. The outer investigation is related to the overturning, sliding and load it is transferring to the ground. We are trying to keep the turnover coefficient at more than 1.5. When it is less than 1, this may cause irreparable damage. We can give examples from the US. We are using 12 different specifications in static calculations. ISC 61400 and Eurocode specifications are the most frequently used ones. And as far as I know, in Sweden, a single foundation designing regulation that will encompass all of these, both of these specifications, is about to be prepared. The construction of the foundation begins with the digging of the foundation. If the ground is rocky, this digging turns into smashing. Lean concrete pouring is considered a very simple construction, but any mistake will negatively impact the structure. You start installing your anchor bucket, following anchorage bucket, bottom equipment and pedestal region equipment start. Perhaps it isn't clear in the photo, but you mount the cutting equipment on these equipment. You place the radial and store equipment on the upper region, and you finish the construction of your foundation. Another important subject is the grounding and piping. The reservation for these should be left in the foundation. Application teams in the field complain mostly about the passing of these pipes. Then you do the concreting and finish your job. 2.5 megawatt turbines generally have 19 to 20 diameter foundations. Of course, this differs depending on the ground conditions. 450 cubic meters concrete at 50 meters iron. This may give you a clue. Generally, concrete endurance of pedestal region is done one stage above the bottom stage to enhance fatigue endurance. You do the new filling positively in static. You do the grouting between the concrete and this. You do the torquing on anchorages according to the specifications of turbine manufacturers and make the turbine ready to use. I hope I did not bore you. Thank you. I'd like to thank Mert Bey. He really deserves your applause. He gave us very detailed information. Thank you. He didn't skip even one item, especially in the gathering. There are companies, mounting companies, who overturned it in Turkey, unfortunately. As I'm an electrical engineer, I attach more importance to it. You also mentioned it. As you said, the piping and grounding where the pipes are passing through shouldn't be neglected. In regards to electric, you can design your wind turbine in the shape of a star or a big network. If you plan it as a network, you have to define the outputs and the inputs. But maybe the standard foundation design is not suitable for this. So it's important to get the support of an expert engineering company. I want to share with you one of my experiences. Actually, I don't want to take much of your time, but our beloved engineer actually was into a serious trouble. He's from the Ministry of Energy. They went out for testing with a representative of the turbine company. As far as I know, the procedures of our ministry has not yet settled, so there is no preparation beforehand. The number of these tests may increase depending on the responses of the representatives of turbine company and the investor. Mutual communication and trust is important here, because actually, as you know, the real owner of the wind power plant is the Ministry of Energy and Natural Resources. After 49 years it may be different, but as investors we have the right to operate. However, the final owner is the states, so they are free to do tests. So they did an emergency test. They shut down the overspeeding cutout option because the wind is low, and I was waiting down. All of a sudden the wind started to blast. The turbines passed on to overspeeding. They pressed the emergency stop button. That turbine that has a 80 meter height stops in 2 seconds only. It stops suddenly in 2 seconds, and the tower shakes back and forth. We saw that shaking from the ground. For God's sake, it didn't topple down. So they came out of the turbine with white faces, and we had to write it down to the protocol, because this would have ruined the turbine's guarantee. So, I mean, the foundation is critical, both for the turbine manufacturer and the investor. The most critical factor in the field is the foundation. But at the same time, foundations are our great intervention to environment. This is the biggest intervention of wind turbines. We bury it under the land. You said it is 450 cubic meters, but it can be 650 or 800. In Turkey, we are currently constructing power plants with 7, 8, 9 meter per second wind. But as the power is decreasing, we are going to raise the figures. This figure is 130 and 140 in Europe, and we will reach these figures one day. So the foundation is very important. So I thank you for your presentation. I am trying to divide 15 minutes between you. Our first panelist finished in 10 minutes. Mert Bey finished in 15 minutes. So I request the same from Devrim Bey. He is in the service department of Energy Unit Management. He graduated from ODTÜ and METÜ Mechanical Engineering in 1999. I guess after his military service he joined Alstom. In Edemak you worked in the industrial department, so you worked in the dark areas. Then you started to work in Siemens in 2004. You have been working in Siemens since 2004 in Energy Power Plant Group, and then since 2009 in Renewable Energy. Yes, the floor is yours. Thank you. As the chairman mentioned, I represent the service department of the manufacturer company. We are taking over this marathon at the last plateau. Indeed, we can say a second run will begin. These fields are generally managed by long-term maintenance agreements. I am talking about time periods of 5 years, 10 years, 15 years or 20 years. Again, as Scribe talked about it, we have to work at tough conditions. So we need to apply a different strategy, a different methodology in regards to service. Again, as Murat Bey mentioned, different equipment structures at different energy power plants. Due to this, we need to make a difference in service, in wind service. Thus, providing service to wind power plants, you need to be invisible, because the main principle of being successful in the wind power plants servicing the wind turbines that are in operation. The more a facility's turbine produces electric, the less it stops due to malfunction, the better it is. Thus, what differs us from other wind power plants is that you shouldn't be present so much in the field. This may sound contradictory, but this is it. The turbines should always be producing energy. What are the methodologies we are developing for this? What are we doing? These are different systems. We are measuring different parameters. For instance, the time between two malfunctions, or the percentage of solving the malfunction at the first glance or intervention, or being available, are the examples of different parameters. And the final target here is to enable turbines operate as long as possible and to benefit from this. Today I want to talk about remote monitoring systems in my presentation. These systems are related to the subjects I mentioned. As I said, you shouldn't be in the field so much. This may not be so possible physically, because your technical team is present in the field one way or another, but you try to decrease the load of that team and intervene from the outside, and you should have the authority to do that. Besides this, as Murat Bey mentioned, there are great uncertainties in the operational conditions of the power plants. The first uncertainty here is the wind itself. So the structure of the service should be flexible. We have some practices. For example, when the wind is low, we try to do maintenance, or we increase the number of our teams and try to finish our job quickly, providing the necessary logistics providing logistics at the right time, at the right place. Again, as I said, the field's conditions are very tough, so it's not easy to offer logistic services. Another subject is as I said, is the remote monitoring systems. What is Siemens doing for these systems? What is its solutions? I'd like to talk about this. At Siemens, we have different packages in the frame of the maintenance agreements. We are offering different solutions. These solutions are processes that extend to 5 to 20 years and that encompasses the operational period. In remote monitoring systems, we have a comprehensive package which is called RDS Premium. This is offered as a standard in service agreements. As you can see, this includes vibration definitions, updates, identification and support, and monitoring systems available for 7 days, 24 hours. As I mentioned, the final aim of this is to increase the performance of turbines as much as possible and make turbines permanent in operation. Besides, we offer 3 different packages. These are basic, advanced, and premium packages. They include subdivisions. We combined different services in certain packages. As I said, RDS Premium is the most comprehensive one. But as I said, RDS Premium is offered as a standard in all service agreements. But when maintenance agreements expire, which is 5 years later or 10 years later, investor companies may demand to sustain these services. So we discuss the packages with them. We provide infrastructure according to their requirements. And as you can see, in basic and advanced packages, vibration analysis is optional. Sorry, it is only offered in the advanced package. And in the basic package, software updates are again optional. When we look at the equipment of remote control systems, remote monitoring systems, the measuring devices positioned on top of critical components transmit data to SCADA server, and this data is transmitted to Siemens monitoring center and also to our customers via internet. Then in the monitoring center, as I said before, this system operates for 7 days and 24 hours a day. So we conduct analysis, and if this is a common breakdown code and if exists in the system, we can intervene instantly and engage the turbines. Besides this, the incoming vibration malfunctions or alarms are examined individually because vibration malfunctions or alarms are generally the precursor for slowly developing malfunctions. So the technical team analyzes them one step forward, and through directives transmitted to technicians in the field by the technical team, different on-site observations and applications can be conducted. The malfunctions on site can be examined. I would like to talk about the subdivisions of the RDS Premium package. One of them is, as I said, the systems that are monitored for 7 days and 24 hours a day. We can take a look at some statistical data. First of all, I think this is a very huge figure, 85%. For instance, in 2012, we received 250,000 events, and almost 85% of them were solved through remote monitoring system and remote intervention system. So without any need for on-site intervention, we solved these malfunctions remotely. The average reaction time is 10 minutes, and the first 99.4% of this were solved in an hour. Except as at Siemens, we are offering this service globally to new turbines. 7,000 turbines. We are offering this service from 3 different locations. These are England, Denmark, and Germany. The turbines in Turkey are currently monitored from Germany. This monitoring includes various parameters. These include oil temperature, pressure levels, and also ambient temperature, voltage, and similar velocity data can be monitored. Another aspect is the diagnostic supporting. This is divided into 4 or 5 divisions. One of them is technical support, or we can say technical engineering support. At any possible malfunctions on site, this technical team examines all malfunctions received by the system that is monitored for 24 hours for 7 days. And this technical team has different levels of expertise. They can conduct different actions according to the content of the malfunction. This chain includes a wide spectrum from technical support in the remote monitoring center to the technical staff in the field. Also, we have a support unit dealing with SCADA only. At specific problems, again through remote access, we can solve the problems. The final step of this diagnostic support is the support related to turbine control system WTC. It controls almost 3000 parameters of each turbine. These parameters are held at certain sensitivities. It observes their deviations, enables intervention to these deviations when necessary, and this guarantees the right setup for the turbines. Another, let's say, TWEC is software updates. All of these systems are of course programmed according to the software. So this software should be improved and upgraded at certain time intervals. And we need to take precautions against viruses. Again, through remote access. Software can be updated. These software updates are generally conducted at the average of 3 months intervals. As I said, through remote access, sometimes by stopping the turbines and sometimes not, we can do these updates. These updates include the turbine control system, SCADA system, high performance pilot, which is the interface systems that enables compliant operation with the network, and the software in vibration monitoring systems, which we call the TCM. And the final step is the vibration analysis. I mentioned it before. This vibration analysis is a system available in the most comprehensive package and in the standard service agreements, but this isn't available in the basic and advanced packages, only optional. Again, when we look at these statistical values, annually almost 20,000 vibration analyses are conducted. We reached 90% error detection ratio in a year, and this rises to 96% in the main bearing. The M system that stores the data received from the vibration analysis system, the ratio is 99.92%, which is very high. I am not going to talk much about the advantages of vibration analysis because I mentioned them at the beginning of my speech. Here there is one characteristic. Vibration analysis system can track the global fleet, so I mean Siemens monitors the whole fleet within the system and obtain the data. And if this data detects a developing malfunction, it masks this to the other units in the fleet and can detect the developing malfunctions earlier. Again, when we look at the equipment of this, we have a separate server for this, which is the TCM server. And there are sensor measuring devices, speed measuring devices, vibration measuring devices, And there is also an interface computer which is called the M system that stores these devices. As it is in other systems, vibration measurements vary according to turbine types and models at different locations in different lasers. I can say we are one of the first companies to make this difference. In 1998, Graham and Yule designed this, and then they commenced to mass production. And as of today, this system is a standard and installed system in direct drives and 2.3 turbines. I would like to give examples of two events. One is the slowly developing main bearing malfunction. As you can see, there is vibration alarm in the main bearing, and the whole organization is done within 4 weeks. By the way, a lifter and other equipment should be available to repair this main bearing. So this equipment is organized, and the team conducts the work on site. And during this period, the state can keep this turbine. The second one is the fast developing malfunctions. Here, the benefit of vibration systems is that in fast developing malfunctions, you need to stop the device at a certain point. So when it detects such a malfunction, it shuts down and prevents other components from breakdown. Finally, following the vibration analysis, these can be reported at certain intervals to our customers on demand. Also, as I said, our customers or users can log into the system and get the raw data and conduct their own analysis. Thank you.
Şimdi dünyada giderek artan bir yüzen, yani deniz aşırı rüzgar türleri floating denen yüzer tip temeller var. Onunla ilgili de deneme uygulamaları başarıyla başlamış vaziyette 500 gigawattlık falan bir potansiyel var bildiğim kadarıyla. O konuda çok ilerleyecek ve Türkiye gibi denizleri derin olan ülkelerde çok büyük imkan yaratacak. Kuzey Denizi'nde çok var biliyorsunuz deniz aşırı türbinler ama sığ olduğu için yapılabiliyor. Bu yeni teknoloji o da çok büyük imkan için Türkiye için de yaratacak. Şimdi Devrim Bey'in bahsettiği konularla ilgili olarak da birkaç husus var. Bu condition monitoring sistemi, vibration, vibrasyon ölçüm sistemleri bu zamana kadar hep rüzgar türbini firmaların ekstra paketler olarak, isteğe bağlı olarak satılan şeylerdi. Ve zaten Devrim Beyler de aslında servis paketinin içinde işte ekstra paketler olarak fiyatları biraz arttırarak sunuyorlar. Bence bu yatırımcı açısından aslında çok önemli. Şimdi bizim şu anda kendi türbünün bakımını yapabilen bildiğim kadarıyla bir tane yatırımcımız var. O da o türbünü veren firmanın esnekliğinden kaynaklanıyor. Pek çok rüzgar türbünü firması burada emre amadelik vererek, üretim garantisine ilgili sorumluluk üstlenerek türbünlerinin bakımını bırakmak istemiyorlar. Çünkü bu ciddi de hem kazanç hem de ciddi de bir risk ve sorumluluk. Yedek malzemelerini getiriyorlar, elemanlarını yetiştiriyorlar, bekletiyorlar. Yani o yatırımcının yapması gerçekten ne kadar mantıklı tartışılır. Uluslararası vizyonu olan bir yatırımcıysa eyvallah. Ya bunu yapan zorlu. Uluslararası vizyonu olduğu için kendi ekibini zaten endüstriyel türbinlerde kurmuştu. Rüzgara da bunu yaydı. GE ona müsaade etti. Ama ne Vestas bana ki en katısı Vestas'tır. İlk başta böyle olmamasına rağmen güçlü bir santrali Çeşme Alıcı'nın kurulduğunda Vestas nasıl bakım yapılacağını öğretmiş öyle gitmiştir aslında. Ama sonra artık kimseye vermemeye başlamıştır. Herhalde yaşadığı tecrübelerden. O yüzden yatırımcının bu condition monitoring sistemi, vibration ölçüm sistemlerini mecbur kılarak türbinlerinden istemesine dayatması önemli. Uzaktan kumanda sistemi çok önemli. Türkiye'de giderek bazı yatırımcılarımız pek çok santrale sahip olmaya başladı. Portföyleri var. Bunun için hidroelektrik de var, rüzgar da var, birden çok rüzgar santrali var, termikler var. Ve artık TEİAŞ'ın yük teyzi merkezleri gibi özel yük teyzi merkezleri kurulmaya başlandı. Gene burada vizyon olarak böyle bir düşünce varsa altyapıyı buna göre kurdurmak da önemli. Tabi burada da iletişim yani iletişim şebekesinin santraller daha başında ya kuş uçmaz değil ama kervan geçmez yerler. Rüzgarın olduğu yerde kuşlar uçuyorlar, yukarıdan da uçsalar. O şekilde bir altyapıyı sağlam bir iletişim altyapısını kurmazsanız bu şeyi tabii yapamazsınız. Her halükarda ama ne kadar uzaktan müdahale imkanı da olsa ve Türk firmalarını pek de istemeseler sizin sürekli sahada operasyonda insanlarınız olacak. Servise gelen arkadaşlar belli zamanlarda gelecekler. Zaten görmeyeceğiz. Onlar planlı bakım yapacaklar. Planlı bakımda da rüzgar yokken yapacaklar. Fark etmeyeceğiz varlıklarını. Ama rüzgar sırasında bir problem olduğunda orada bulunan operasyondaki arkadaşları en azından hiç olmazsa bir gidip uzaktan iletişimde, rüzgarın yoğun olduğu zaman iletişimde kesilebiliyor. Bir aşağıdaki butona bir basıp bir reset etmesini, sağlama yetkisini istemeniz lazım ürün firmasından. Bu çok önemli bir şey. Müservisin gelmesi 2 saat sürer, en yakın yerde bile olsalar dağın başına gecenin bir vakti ama sizin orada bekleyen nöbetçileriniz var. Rüzgar santralinin işletme personeli çok azdır biliyorsunuz. 4 vadiye şalt tesisini işletecek olan teknisyenler vardır. Bir de işletme müdürü, gece zaten olmaz. Gece vadisinde 2 kişi bekler, bir de bekçi vardır yani 3 kişi. Bir kişi bu selahiyet sahibi olursa 1-2 saatte bu rüzgar şeyden belki tasarruf olur. Çünkü reset edince bazen türbinler toparlayıp kendi çalışmaya başlayabiliyorlar. Bilmiyorum pek hoşumuza gitmez ama ben yine söylemek istedim. Ben yaptırmıştım yani, yazdırmıştım. Biliyorum onu sağlamaya çalışıyorsunuz ama. Şimdi ben konuşmayı açarken bir hata yapma yüzünden özür diliyorum. Yani yatırımcı tarafı yok diyordum. Beni bu revize programı atlattı. Ali Aydar Bey var, Borsan Yemidavur'da. Ama ondan yine özür dileyip son sözü size vereceğim. Çünkü Siemens Energon'dan Ali Bey'i davet edelim. O da bir üretici firma ve servisle ilgili konuşacak. Ali Bey dinledikten sonra yatırımcıyı en son olarak dinleyelim. Ali Bey buyurun. Ben biraz geçmiş sorumuz bir kısa kendinizi tanıtırsanız.
Aslında sorun başında var.
Tamam. Ben çok konuşup sizi şey yaptım değil mi? Zamanınız şey yaptım. Tamam.
My name is Halil Durutürk. I'm working in Erancon Service Limited company. I'm the company manager currently. I'm an electrical engineer, just like Murat Bey. I graduated from Istanbul University. Then I had master's degree from University of Nottingham. I am 43 years old. I have a daughter and I'm married. I've been working in Enercon for about 15 years and I worked at different departments in Enercon. In this presentation, I would like to talk about the general structure of Enercon in the international arena. Then I will talk about mounting and service, which is the subject of this session. Enercon was founded in 1984 and expanded its service network in 1993, beginning from Germany, and it's a wind turbine manufacturer. They founded the first wind power plant in Germian village. This has 3 turbines. 1 year later, they started to work with us. In 1999, they founded Enercon Service Limited company, and there was a cooling period till 2006. With the act that was enacted, we conducted our first project Mary. In 2010, they terminated a partnership with an investor in Turkey, and then Enercon started to become a company liable to Enercon Germany. It is important for us to mention Enercon's international impact. We are in fact acting as a long arm of the Enercon Germany. Instead of talking about Turkey alone, this company has 5,600 employees. It has a network distributed almost all around the world. And also in Turkey, we are trying to establish service network. These service networks are at the regions defined by the investors. As you see, we establish service networks at these colored points. Our center is in Izmir for logistic purposes. We have customer services in Istanbul to be close to the investors, and we are trying to establish the standards Enercon founded with these networks in Turkey. Mert Bey has a visual presentation, but I also want to show some pictures. This is the general structure of the field before the mounting. First of all, access roads to the field are created. This is to get to the foundation of the turbines, and for first operation, the mounting roads are repaired. There are one or two critical points in this mounting roads. One of them is the width of the road. The road should be wide enough to carry the load easily. It should be a plain and compressed ground to avoid any accidents, and proper management of turning diameters. These are very important criteria because this is not a project in Turkey. If it is not designed properly, then such things can happen due to turning diameters. They are trying to find different solutions for this. Here, the wing should cover the turning diameter easily, as you see. Then, after the roads are completed, then we have studies for foundations. I will not go into the technical details. It is the diggings for foundation, mounting of the pipes for electric cables and pipes, and as Mert Bey said, and it's very important, pouring of the concrete. This picture was not actually that wide. The mounting to the foundation bucket, and as you know, they have no such great depths. It's only 1.5 to 2 meter depth. They have very heavy steel equipment, and this steel equipment requires heavy workmanship, the pouring of the concrete according to certain standards, and the finishing up of the foundation. Then, after the foundation is finished, there comes the drainage. Drainage is important because it is generally done in the watery lands and the covering of the foundation. Thus, we completed the roads and we did the foundation. Then electric works begin. Depending on the power of the project, there can be 154 kilowatt switch center, 154 or 380 volts, and high voltage transformers, and the joint works begin with electric. Following the preparation of our foundation, the preparation of the field is very critical, especially for the safety of the workers and work safety. It has 100 to 150 tons, and the lifter should be on a solid ground. The mounting places should be plain and compressed, and efficient network should be provided. So, a precise and careful engineering study is required for these lifter fields, and this should be done on site. There are some pictures about this. Although it's not, even if it's not concrete, it should be compressed properly. Here you can see the foundation, and here is the lifter. I am skipping them rapidly, I'm sorry for this. Now our foundation is ready, electric infrastructure is ready, construction work is ready. Now transportation can start. There can be international transportations, shipments are available, sailing vessels and ships are frequently used in transportation. They benefit from the wind energy, save fuel and carry these materials internationally. And our wind facility is in Turkey. Concrete facilities are in Turkey, and their transportation in Turkey should be organized in detail. Murat Bey also showed his picture resembles the mine. The wing protrudes. We need to be careful about this during transportation. Following the transportation, we will do the mounting by the lifter. This can be a crawler crane or a mobile one, and the mechanical mounting begins. And the electric units, including cabins, transformers, medium voltage transformers, system out transformers are mounted into the system. For the towers, if it is a steel tower, 3 or 4 pieces of a steel tower are brought together one on top of the other. This is like a Lego, but not as simple as Lego, of course. It has very strict technical details. If it is a concrete tower, then we transport it to the center in segments, and these segments are mounted individually. And then the engine room is prepared for mounting. Then we lift the wings with the hub. This is still something that I feel very excited about. I've been in this sector for about 15 years. It is lifted with the one hook of the lifter, and the twisting movement is given by pressing from the one wing, and as you see, lifted to the top, and so the turbine mounting is finished. Following the mechanical mounting of the foundation, the electric cables, which are called the reed connection, are mounted and operated. So the project step and the mounting step of the wind turbines is now finished. Then comes the service controls. Enercon technically enables the wind turbines to serve to the investors for long periods of time. So for this reason, it establishes a powerful service network and always offers service to investors. We apologize from fields. We try to establish teams in the sites as much as possible. And for this, our first prerequisite is that we demand from investors to sign a contract called the Enercon EPK. This contract gives 15 or 20 years of maintenance and repair. Thus, the investor is secure and comfortable for its future only just by signing an EPK agreement without adding maintenance, intervention to malfunctions, and budget and planning to the issues aroused in the main components. This generally provides a 97 guarantee. With the help of EPK, this is also relevant for wind turbine manufacturers. The investors can get credit very easily, so they secure their long-term investments. We have 4 key maintenance at Enercon. These are visual maintenance, lubricated maintenance, mechanical maintenance, and the electrical maintenance. Done in every 3 months. The time periods is very critical, as the wind turbines should always be in operation. We try to keep these time periods as low as possible. The anticipated service is the 14-hour maintenance in a year. Periodic maintenance is important, but of course not distressing the investor. Early delivery in basins or high availability and fast retrofitting of some updates. These are enabled, so this gives advantages to the investor for the long-term basis. We established a very crowded team to control the power plants Enercon established in Turkey. Our team consists of 313 people, and each service region includes in electrical engineering relevant technicians. So this is our service network. We have a very powerful organization structure in order to support the investor. We give the trainings personally. We control work safety. We have teams established individually for generators and wings. Since 1999, these processes are ongoing. One of the most critical aspects in intervention to malfunctions is the spare parts. We have small storerooms in the wind power plants, and we have a main storeroom in Izmir center. So we try to provide a very fast logistic support. This is a very important criteria for power plants with high availability ratio. You mean the time? Okay. Fast reaction time is important for us. Again, as Devin Bey said, system controlling with remote SCADA systems, resetting, and customer control over web-based programs. These are the critical criteria for the investors. Thus, we try to keep unavailability to much over 97. In Bozcaada power plant from 2007 to 2012, sorry, it is from 2001 to 2012, and the unavailability is 99. At Enercon service, we try to create satisfied customers. There is wind, and the wind turbine should be ready to operate with the wind, and in long term, it is to fulfill customers' expectations. There are many surveys conducted for these purposes. We will try to conduct such an survey. My presentation is finished. Maybe there will be some questions, or I'm trying to create some time for questions. Okay, at first we better listen to Ali Haydar Bey and then go comments to the questions and answers. Then I finish here. Thank you. Enercon service attaches importance to the kilowatt hour that is produced since its beginning. Actually, he is also a very serious energy investor. The more production there will be, the more advantages Enercon is. For instance, there is no such thing in Vestas. Finally, let's listen to Ali Haydar Bey and have some investors' perspective. Ali Haydar Bey is the senior planning expert of Borusan BMW. Can you briefly introduce yourself? BMW is into renewable energy. BMW is an important company in Germany, and it has strategical decisions for Turkey. Now I'll give the floor to you. Thank you, dear Chairman. Esteemed participants, I would like to greet you with respect.
Enercon servis konsepti biraz üretimden de üretilen kilowatt hour'dan da bir şey yaklaşımıyla hep baştan beri kurduğu için aslında ciddi bir de enerji yatırımcısı aynı zamanda. Üretimden pay alarak. Öyle olunca tabii üretim ne kadar çok olursa o kadar Enercon da bundan fayda sağladığı için ona göre bir şey oluyor. Diğer türlü firmanın da benzer bir takım şeyleri var ama mesela Vestas'ta yok yani böyle bir şey. Şimdi son olarak Ali Haydar Bey'i dinleyelim. Yatırımcı perspektifinden bunları dinledikten sonra toparlamayı ondan isteyelim. Ali Haydar Bey, Borusan BMW'nin kıdemli planlama uzmanı. Bir kısa kendinizi tanıtırsanız sevinirim. Borusan BMW Türkiye'nin biliyorsunuz yenilenebilir enerji yayıncı yatırımcı gruplarından bir tanesi. BMW zaten Almanya'da bir dev. Ve Türkiye'de de stratejik kararları verir. Sadece yenilenebilir yatırımları yapıyorlar. Ciddi bir hedefleri var. Buyurun.
Teşekkür ediyorum Sayın Başkan. Kıymetli katılımcılar, hepinizi saygıyla selamlıyorum.
My name is Ali Haydar Çakmak. I've been working in energy sector in Borusan since 2010. Since 2010, I mostly participate in the management part of this company. I worked in the unit responsible for production. Firstly, I was the operating and maintenance engineer. I was actively on site, so I experienced the production. As of today, I am the senior planning expert. I am senior mechanical engineer. I am married and I have no children yet. Borusan ENBV Energy participated later on to energy, but it is assertive. As Murat Bey said, our target is renewable energy. Currently, we are operating a 110 megawatt portfolio. 60 megawatt of this is for the wind. 50 megawatt is for the hydroelectric. If I'm not wrong, I think that we hosted you in Bandırma. Yes, actually we have some memories with Murat Bey, both for the Vestas and all energy. He works with him. As I said, our target is renewable energy. We are trying to exist and expand in this sector. You all know Borusan. It is known for its industrial history, mainly working in iron and steel sector and distribution sector. The German partner MBWAG is the third biggest energy manufacturing company. This German partner is operating in Baden-Württemberg, both in manufacturing and distribution in Germany. A couple of minutes ago, our colleagues talked about the marathon. I'm on the production side and also on the operational part of the production. We are still known as investors. I guess this is due to the motivation of our sector and our market. We are a developing market. We focus excessively on investments. All players aim to expand. For instance, I still represent the investor side, not the manufacturer. Actually, the final objective is to produce and sell the energy. I am at the end of this chain. During production, during operation of the wind turbines, I would like to talk about the problems we encounter. You have listened to many things about this throughout the day, so I did some revisions. When we reach 2020 targets with today's perspective, with today's acceptances, with today's approaches, I would like to talk about which challenges and problems we will face. I talked about the position of Borusan. Now I would like to briefly mention our own targets and then talk about the challenges in Turkey. As I mentioned before, in 2020 we are planning and aiming to have 2000 megawatt installed capacity, most of which is based on renewable energy resources. This is our strategic position. I know this is a bit assertive target. We don't have much time. But when we think about the megawatt target of Republic of Turkey in its 100th anniversary, I believe it will be beneficial for investors and players like us to start with such amounts to reach the target. 1500 megawatt installed capacity out of this 2000 will be based on wind. So we are aiming to become a company growing with the wind and become a leader in the wind sector. In these strategy studies, as I mentioned, the motivation and concentration is always on at the investment. Actually, when you look at the life cycle of a wind power plant, developments and investments do not constitute a great part of the wind power plants. Depending on the term of your license, will operate for 49 or 45 years. And everything you do in the development and investment steps will constitute and define this 49 years period. I want to criticize myself. Investors like us always focus on the investment perspective when investing. How much investment cost should I tolerate? How many projects and licenses should I have? Which turbine supplier company should I work with? Generally, they focus on these items. So do we. I guess this is perhaps due to my position in the company. I am in the team that has to focus on operational items. In fact, our company is at the preparation phase. Our company is still focusing on development and investment. As I said before, if you continue to operate power plants with the present acceptance and present perspectives in 2020, what will we and other companies encounter when we reach the 20,000 megawatt capacity? Let me talk about this. I want to share with you some statistical figures from TWEC's statistical data dated 2013. By the way, these figures are always updated. They say it's like stock market, but it is not. It does not go up. Sorry, it does not decrease, it always goes up. In the report I read, the installed capacity is 2,915 megawatts. I guess this has already increased. The number of installed capacity power plants in operation is 68. Actually, this was not only a problem specific to wind power plants. Different from hydroelectric and natural gas power plants, the wind power plants can handle minimum number of stuff. Actually, you are not adding the wind turbines. I am looking from the investor perspective. You are only responsible for 154 kilowatt switch field. Your staff out there and supporting staff. It can be the security and the personnel responsible for logistics. Observe only 154 kilowatt hour switch field and do the necessary maneuvers, interventions, etc. With a rough calculation, let's say 43 or 50 megawatts. This 2,915 megawatts installed capacity is consisted of this wind turbines. You have 4 shifts here. Your staff that are the operational technicians and operational personnel or other technicians only observe 150 kilovolt switch field. These are expert employees. Most of them are graduated from academies, and these academies are not widespread. And you have to employ people for this 4 shifts, both due to legal obligations and your business model. Let me share with you the data of my company. Right now we are operating a 60 megawatt facility. According to the calculation we made, depending on the legal obligations and our business model, we need 4.3 men per hour to run the 4 shifts, and this corresponds to 5 employees. We are going to employ 5 valuable colleagues that are technically competent and graduated from academies just to observe 154 kilovolt switch field and intervene when necessary. And we hear such comments like, we haven't experienced big malfunctions in 154 kilovolts per hour. Maintenance is generally the turbine maintenance. The company should observe, report, and TEH has that communication. This is just why we employ such 5 valuable technicians. We are currently operating 1,277 wind turbines in 68 fields. Most of them work with unavailability guarantee that are under the full service guarantee, with no intervention from the manufacturer, whether unintentionally or on purpose, or due to the approach of supplier company, as Murat Bey said. We operate and maintain these wind turbines through unavailability agreements in which you do not think much and you go home comfortably and sleep well with 10 to 12, 15 years of a long time period. We have projections for 2020 according to our targets, but we realize there are some challenges. I want to share this with you, but I'm going to do this with 20,000 megawatt projections. With the same approach, same business models, if we continue on wind turbine and wind field operations, when we hopefully reach 2020 targets, what the challenges would be. I would like to talk about this. Again, with a rough calculation, we have almost 450 wind power plant in 2023, and when we reach 20,000 megawatt target. When we continue to employ these 5 valuable technicians operating personnel or staff or operating technician, whatever you call them, just to observe. In 2023, we will have 2,250 operating technicians. So we need 1,910 operating technicians. Colleagues with operating origin know that a very rare number of schools give this education. Approximately 100 people are graduated from these schools. You cannot employ all of them in wind. There are very different sectors in energy, and they can also work in different business models. They can work in hydroelectric and natural gas power plants. So for this 1,910 new operating technicians, our education structure does not seem efficient to educate such amount of people. What if we continue that way? Let's look at the turbines. If we continue to work with 10 to 15 years of a long-term maintenance contract in 2023, first of all, turbine supplier may have problems with the service, as this sector do not focus on operating. Operating costs are not examined in detail. Everybody focuses on investments. The biggest share in operating costs goes to turbine maintenance expenses. When we come to 2023, these are irritating, I know. First, I talked about employment, said that it can be unnecessary. Secondly, one of turbine supplier companies' most crucial source of income will be aspired and investigated. Actually, this is not what I want to mention. These problems exist, and we need to solve them when we reach 2023 target. What shall we do to solve them? Where can we dislocate the personnel that we consider as unnecessary in wind to which positions in the same sector? How can we reduce maintenance costs? Or how can we make the competition reliable? When we list the problems and the solutions that we need to think about as a sector till 2023, actually there's an overqualified team responsible for 154 kilowatt per hour switch, and as Devrim Bey said, turbines can be remotely monitored and most of the malfunctions can be repaired remotely. Switch fields also can be added to this process. This is not like discovering the world. This is applied in the world. And if your connection points let this, you don't have to employ people just for this work. And TWEC communications are now automatical. We don't need these colleagues. We as manufacturers can establish what Devrim Bey did at Siemens or what other colleagues did at their turbines in our locations and in our headquarters. We can monitor our turbines and switch fields when necessary, intervene and save costs. This is what we call unmanned facility operation. As I said, everybody will decrease spare parts costs, maintenance costs. But they said maintenance companies are generally not into know-how process. If you perceive this as a know-how transfer, or if you are trying to possess the valuable thing the other company is making money off, of course this company will not want to share any knowledge. In our system, with 100% on availability guarantee and full service guarantee and with contracts, we need a structure that is operated with joint interventions and approaches of facility teams, maintenance teams, service representatives of turbine supplier companies. Actually, there is such a bad influence in the sector. Turbine companies do not want to share this cake with others. Let me give you some good news. We are making tenders under this concept, and all of the turbine companies lean to it. I mean, most of them, because they are aware that this concept is a necessity for the future. Something is clear. Nobody can maintain turbines as better as the turbine supplier itself. As Murat Bey said, the manufacturer companies actually do not have to deal with maintenance work. We don't have to make our organization full of maintenance stuff, but with its own turbine and with the company of the turbine supplier. If I will be able to maintain these turbines, if I could get 100% guarantee from turbine supplier company, and if I could practice this work, then I can be included into this work with different business models and on a long-term basis. And I can profoundly decrease turbine maintenance costs, which is a problem of competition. Service staff of the turbine supplier companies assisted us in that. They all contributed to this concept with their solution offers. We anticipate this will be the business model for 2023. I do not want to take your time. Thank you very much. If you have any questions, I guess there will be a question and answer session, and I will get them there.
Yes, we are ahead of our time. Actually, I'm not a great talker, but I guess as the subject is the wind, I consumed your time. Thank you, Ali Haydar Bey. As we employ 4.3 or 5 people in the power plant, Enercon has a model. Enercon can operate a shut field, I mean the switch field. Or if there are more than one power plants, then they can install portative items. This may be a way of getting rid of the human barrier. Now, I do not see the bosses I know, but there can be some other bosses who will give us money. So we'd like to give a message to you. When we make a proper calculation, as you know, nobody calculates 49-year period, everybody calculates 25-year period at most. Payback ratio of your investment, the impact is very low. Although you increase turbine price by 20%, you will see the impact will be low. And all companies do this calculation, and they calculate the price accordingly. They are giving to you. Do you think 3 turbines are expensive because of its costs? They give the price according to these high ratios. So do not forget this when calculating. Thank you for your participation. Now, if you have any questions. Yes. Will you briefly introduce yourself and mention the company you are working in? Emrah Pınar, I am mechanical engineer. I want to ask my question to the colleagues who are working freelance. The technical availability in the IEC standards for wind, it is said that you cannot add plant maintenance to these calculations for technical availability. But in the service agreements, I have a plant maintenance of 80 hours at average, and I would not add this to availability. What does availability exclude? Force majeure and some cut. So I want to ask, why do these colleagues do not add the 80 hours? I do not hear your company. From Boydak Enerji. We define these hours. It is almost 15 to 20 hours for some types. We try to hold the 10 hours. This is a necessity. And we also try to keep it low. But in the EPK agreements, the first agreement, these are defined. Yes, these are defined, but I am asking the engineering definition of this. Is there a standard? There is a plant maintenance. I think this is an arbitrary application. As we cannot come close to the turbine when there is a problem, we don't really know the details of the malfunction. Is it a condition for malfunctions or plant maintenance? Let us not turn this into a conversation. It is actually the most critical part of the contract. One needs to puzzle his head to understand this. What you are saying is very right. It is hard to do something. But this formula is very important. Sorry I interrupted, but 97 is a critical position. But we do not negotiate with investors only in contractual basis. We reach 97 and this is it. When it is 97.1, we do not care if you are happy or not. This isn't the perspective of maintenance companies, the service companies. You're not happy for 97.1. We are trying to hold the availability much over 97. I also gave an example. I guess this is also the same in Siemens and in other manufacturers. In Bozcaada, that has been operating since 2001, has not ever decreased under 99. So I reached 97 and I can stop the turbine whenever I want. It's not the case. When you do, you will negatively impact the success of the service company and your own company. I'm sorry, but I want to ask the floor if the spectators if there are any other one to ask questions, because we have limited time. If there is no one, then we can get the second question from you. Do we have any questions? Yes. When these calculations are done in Europe, these are not included in the availability, but in Turkey. Why this is not the case? You mean the plant stops? Yes. Technical availability is defined in this way also in Europe. It is 97. But this is important for contracts. We guarantee 97, but we are going to exceed this. I believe this will be efficient. Yes. I agree with Murat Bey. This can be a bit complicated. This may be for 100% availability. You need to carefully examine the exceptions and you need to see the real amount. You are right that there is a deficiency in standard. Actually, there are two availabilities. There is a percentage of preparation to production for the facility. It is almost 93 or so. This is also into this formula. Then there is a commitment 96, 97, whatever. Investor should think that you do the calculations. If 97 is okay and if you are exceeding this, then give them some share and motivate them. Turbine companies change their attitudes actually. In the past they tried to hold this figure low to save costs. But this means that if you have 20 turbines and one of them just do nothing for a 1 year period, then still you have 97. There is such a dilemma. But then turbine companies realize that the more support I give to manufacturing done by the investor, the more I exist in the market. The mentality has changed. So this is a big change of approach. Ali Haydar Bey gave the messages about it actually. Yes, they come to the turbines and open the door and shake hands. When it comes to shaking hands, they do not sign. We hope Turkish investors will learn more about it and do the bargain and want more. But if there's extra, then they should share. I'm totally favor of standardization. Yes, we hope. I didn't see. Maybe there's a standard. One should search for it. Okay, thank you for your participation. And I'd like to thank panelists.
Sözleşme imzasına geldiğinde bir tülo sözleşme imzalanamıyor. Çünkü bir Türk ona yanaşmıyorlar aslında. Yani maalesef öyle bir gerçek de var. O konu inşallah giderek Müşterimiz daha iyi öğrenecek, daha iyi pazarlık yapacak, daha fazla isteyecek. Ama biraz da ekstra bir şey varsa da onu paylaşmayı da şey yapması lazım derim.
Yani ben tamamen standartlaşması yönündeyim. Yani ortaya
tabii,
standart.
inşallah.
Yani bu HES'lerde veya gaz santrallerinde çok açıktır ve nettir. Hiçbir şekilde
Bir yerde bir standartı vardır belki aslında. Arayıp bulmak lazım. Peki katılımınız için hepinize çok teşekkür ediyorum. Katılımcılara, panelistlere çok teşekkür ederim.